Great. So, hi everyone. Thanks for joining in today for this this webinar. Few points before we start. So I am today. I'm surrounded by RVE's team here in the room in Montreal. We have Amelia, Emma, and Simon that will be monitoring the chat. If you have any questions during the webinar, please feel free to write in the chat your questions. And what we'll do is we're going to monitor the questions, and I'll make sure to reply to those either during the presentation or at the end. Yeah, so that's about the chat. Today's webinar aims to update you on RVE's new products. We have a couple new things that are coming out to the market this year, and we wanted to take some time to reflect on those new products and how they can help you better deploy charging infrastructures in multifamily applications across North America. We have people from Canada, but as well as the United States today on the call. So I'm going to do a binational analysis of the context, doing some referring to the codes and how RVE's products aim to respect the code, the newer regulations and standard in regards to load energy and how to better charge electric cars in multifamily application. As a friendly reminder, if you're not following us on social media, please feel free to do so. We're quite active on LinkedIn as well. It's a great way to just keep track with US product development or industry news. And we're also on YouTube and Instagram. So today, your host for this webinar is myself, David Corbeil, CEO and co-founder of RVE. So for the better part of the last 10 years, I've been focusing on bringing to market with RVE's team solutions to energy problem and how to better give access to home charging to people who wants to drive electric but might be in a difficult situation in terms of electrical infrastructure. So that's the reason I created RVE with our co-founder. And 10 years later, it's going great. We're currently selling new technologies in all the Canadian provinces and more than 35 states in the US. We have deployed over 45,000 charging units. Yeah, great milestones, and really happy to be here today to update you on the newer products that RVE has been working on. Before I jump into the exciting stuff, I will do a bit of a market analysis and regulatory update because there's a lot of changes that are coming in the code, and I think it's important just to reflect on the newer regulations. It will help to explain the technological decisions that we've made with the products we're launching. So as for myself, I am involved on the C343 Standard Committee for Electric Vehicle Energy Management System. I've been contributing on this committee for just a little over 4 years now, and this standard, which is a binational standard for both Canada and the US, should be out later this year. RVE is also involved in the committee for UL 3141 for power control systems that we've been contributing for a little over a year. And we're also involved in the Section 86 of the Canadian Electrical Code, which applies to electric vehicle supply equipment. Quick overview of the most recent regulatory changes. So for Canada, we had in June 2024, the publication of the Canadian Electrical Code 26th edition, which adds just one important rule, which is 8.106.11 for multi-level energy management systems. In the US, in August 24 was a public comment period for the 2026 National Electrical Code. So hopefully we will have a new NEC in place in some jurisdictions in the US in 2026. So that's going well. In September 24, there was a public review for the new standard for electric vehicle energy management system. So there was a full public review, which is typically the later stage of publishing a standard. And in October 2024 was the outline of investigation for power control system. So this means that the work of the subcommittee working on this standard is progressing well, and it's in the last phases of being fully standardized and published. I wanted to just take the time to look at this past history in order to set the right frame to look at some of the definitions that we're going to be using more and more in our daily life as electrical professionals. So there's basically two definitions of the products or the systems in regards to safety. So under CSA C343, we're talking about electric vehicle energy management system, which is defined as a means to control electric vehicle supply equipment loads through the process of connecting, disconnecting, increasing, or reducing electrical power to the loads. If we look on the state side and what UL defines as power control system, the definition goes by electronic devices or assemblies that regulate, monitor, and control the distribution and consumption of electrical power. So I just wanted to share those definitions. All in all, both CSA and UL are aiming to provide a clear framework for standards and OEMs to deploy systems that are code compliant and also set a standard for the way we manage loads for electric cars. If we can just simplify the wording a bit, what is an EV/EMS or PCS? Basically, it's a system that will monitor, analyze, and control EV loads or other type of loads, but in this instance, EV loads. Couple components to make that happen. So starting to get a bit more concrete, and I promise it's the later part of the boring definition section of today's webinar. But I think it's important to just look at the basics. So the EV/EMS or PCS jobs will be to monitor feeders, transformers, main service, then analyze either locally or remotely, communicate with wired or wireless, and control either panel, chargers, branch circuit, or outlets. That's basically what it aims to do. So in a nutshell, if we look at both the Canadian Electrical Code or the National Electrical Code in the US, if those systems are deployed correctly according to local jurisdiction, there will be some relaxation that will enable to not add to the load calculation the EV charger load, which is quite huge in terms of how you can deploy your infrastructure, because it means that you could completely offset EV loads if the system makes it possible to manage the loads at all time without breaking the infrastructure. A specific question that we're getting asked a lot is, can the decision-making of an EV/EMS be located in the cloud? So what's pretty clear to us, at least the way we see those systems, is that everything related to critical decisions must be made locally. They cannot happen on the cloud because we want to make sure that the latency is fail-proof, that we have fail-safe mechanisms that are in place to make sure that if ever that the network goes down, we can make sure that everything is controlled locally and safely. A great example of that, in where we can draw some parallels, is the elevator standard. When you look at the B44 safety code for elevators and escalators, what it says is that every safety systems in regards to emergency braking, overload, elevator positioning needs to be fast and reliable. And these decisions are made locally by controllers that are directly within the elevator, and also often redundant logic to make sure that there's no life-threatening event for elevators. And we believe that the same goes for electric vehicle energy management system. So with that said, I'm jumping into the center of today's presentation and going to introduce you our first product that we're launching in the market this year, which is the Hub. So the Hub of RVE is a EVEMS compatible with all charging solutions. Will monitor and analyze all type of loads at the building level. And the main goal here is to provide a reliable solution for multi-family buildings, whether it's a small building or a large building, doesn't matter. The first thing is always to know what's the power consumption, what are the loads available, and from that, it's easier to deploy new infrastructure. So I'll dig a bit into the different features of this product. So first and foremost, every critical decisions are done locally, meaning that if the network goes down, there's no safety risk, and we'll make sure that we control and stop charging if there's ever any communication problem. We will maximize dynamically the charging, so knowing which car receive how many amounts of energy, and based on the building's level energy available, we can choose who to charge first. The Hub enables to monitor up to 7 feeders or 15 CTs with flexible Rogowski CTs or split core CTs. It can control up to 120 DCC plus and up to 30 SMP plus, which we'll see a little later in the presentation, via a backnet connection. When you order a Hub, it comes with factory setting for all the safety requirements to go through certification. We provide you with the hard-coded settings so nobody can change them. That being said, we have a local display available on the unit that enables you to track down the 12-month peak of your building's different feeders. So that's the data that you can use to do EPR, electrical planning report, for example, according to code, where you have 12 months of data available locally on the unit and also available on our portal. Speaking of portal, the Hub comes with a few features in regards to energy monitoring and consumption. The intent being to provide transparency of data and to provide accuracy of what's the available power within a building if there's no EV, and how can we plan to electrify when we'll have 100% EV, for example. take a sip of water. So we have, excuse me. So we have plenty of technical documentations that are available on the website right now. So if you want to get a look into it, please feel free to do so. There's plenty to read out there, or feel free to ask your questions in the chat. Excuse me again. In terms of various application, so we have people on the call from both Canada and the United States. That's good news. The hub is really flexible, so we'll work on 3-phase systems, 600 volt, 40 volts. Will work for 208 3-phase and single-phase systems. In order to kind of show you what would be a typical scenario of installation, we have right here a typical townhome or row homes 40-unit building where where the main feed is a 120 volt main service, and then we have 3 single-phase sub-feeders that are feeding the meters going to each unit. So in this case, the context that we would be looking at is the context 4, which is a single-phase 240 volt main service. Then we would be monitoring the main service, which equals to 1 feeder. We would have 3 single-phase sub-feeders, so that the product requirement to order for pricing is fairly simple. It's basically 1 hub 15G1, which is the main product, and then you would be adding 4 hub feeder. That's for the CTs, Rogowski, and the software to handle the loads, and including the code 4-13. Speaking of CTs, we include all the CTs with our units. So we have from 100 amp to 5,000 amp flexible Rogowski CTs that are included with 25 meters of rope. It's also possible to request for extra length, so up to 50 meters of rope, but in most cases, 25 meter is more than enough. Important to note that the hub is only compatible with RVE CTs. The reason being that we calibrate everything at the factory before shipping our units. So if you have any questions or projects where you think the hub could be useful, feel free to write us at rve.ca or at sales@rve.ca. Then once we've covered the EV EMS part, or the skeleton of a project, which is to maybe deploy a hub in a shared infrastructure building where we have an EV panel that will feed dozens of chargers, or if you have connection to the meter, so typically in the smaller buildings, you might have the meters available nearby the parking lot, where it makes sense to take the power directly from there. So depending on which of the two situations you have, we have 2 types of control system at RVE. I'm going to start with shared infrastructure application and introduce you to the SMP Plus. The SMP is a smart metering panel that aims really to help with rental properties, high-rises, where we have a dedicated EV infrastructure that needs some power management, that needs some billing, and that's exactly where the SMP will enable to power more cars with less. So the goal of the smart metering panel is to enable to connect a maximum of EV chargers to the smallest infrastructure possible, while maintaining equity of charging so that everybody gets a full charge every morning, but without breaking the bank. So protecting the infrastructure, reducing peak demand charges that can get really expensive if there's too many electric cars, and also provide certified kilowatt-hour billing by Measurement Canada. That's a really important one because in rental properties or even condos, oftentimes people want to make sure that they're not paying for the neighbor's electricity for their cars, and that's really a key element of this product. Also important to note, the SMP is compatible with all brands of distribution panels and all charging stations. So it's really a product that is super flexible. It's agnostic to everything on the market, which makes it much easier to deploy. In terms of its design, it is made for obviously some large-scale deployment. So we have buildings where we have SMPs that will eventually power, hundreds of cars. And to make sure we protect the infrastructure, well, we've included some features that enables us to do multi-level energy management system. That's really the only way to comply with Rule 8-106-11. It's to have CTs that monitors both the main service and the sub feeders, but that also have relays with fail-safe features indeed that will make sure that if there's ever a miscommunication along the way, that we can stop the charging and assess the trouble if ever there's one. We request to have Ethernet connection for us to provide real-time monitoring or consumption data. But if the internet goes down, it doesn't matter in terms of all the critical and decisions, everything will run smoothly. A question that I get quite often also is, how does the algorithm work? How does it prioritize different users? So since we're monitoring each individual branches, we know exactly how much car A received in terms of energy in the last 12 hours, and car B, how much energy they got. So we're able to balance not only the power going to each car, but also to balance the loads. Because EV chargers at 208 volt are single-phase devices, but we're almost always on three-phase systems. So the algorithm will also take that into account to make sure that we balance the phases, which will help transformers and hopefully give it more life longevity. Again, we have plenty of wonderful technical documentation that are available on the website, or feel free to reach out to our team if you want to see it for project deployment. Here on the screen, we have a single line diagram of a typical project where we would have a limitation at the main service level. So we would want to monitor the main service with a hub, for example, that can speak backnet through a RS-485 connection to the different SMPs that would be fed by a transformer that is just for the EV panel, for example. So that's a pretty typical installation that we see quite often in Canada, where we have 600 volt design. The same could go for the United States, obviously. But in this case, the beauty of monitoring both the main service and the sub panel for EVs enables us to subtract from the load calculation all the EV loads and basically maximize when we're charging cars depending on real-time consumption of the building. So really interesting features that are developed with the hub and SMP configuration, and hopefully that helps you win more jobs in the future. As far as factory setting goes, what we require when we get an order is that we get the max amperage per products that you are allowing us to control, meaning that when we certify our products before we ship it to the customers, we make sure that we hard code all the critical decisions directly at the factory. The reason being that we don't want the end users to be able to play with the software or through an apps and change everything that is kind of mission critical. So that's the reason why RVE takes that responsibility out of your hands. We handle all that programmation. So when our units gets to the field, your electricians, really what they have to do is do the wiring, is connect the power, which they're really great at, and they leave us all the programming that needs to happen. So it provides you with a seamless deployment. The SMP comes with the RVE Connect Portal with the intent of providing visibility in terms of who's charging, what's the consumption of the different access point, and also enables you with quarterly free report for all the billing of the chargers. So there's two ways to do billing with the SMP. The first one is a quarterly report with all the consumption and Measurement Canada certified reporting that can be handled by the homeowner association. The other way is to provide your customers with the API for billing. So there's plenty of software out there that can handle billing for a fee. There's also a lot of condo manager software that we can integrate with that can provide the billing service for a really affordable price. And that's really what we're after, is to minimize the recurring fees of those charging infrastructure and enable to reduce the cost or the burden of recurring fees to customers in order to make charging more accessible. So that completes my presentation around the SMP for larger buildings and rental properties. I'm now going to switch to the DCC Plus, a product that aims to help mostly row houses, townhomes, smaller buildings that have dedicated meters that are accessible nearby the parking lot. So the DCC Plus is an evolution of our current DCCs with a little plus, meaning that it can be connected through BACnet directly to the hub. Good news, it's compatible with all the DCCs that are currently installed. When we launched the product fully during the later part of the year, it will be able to operate both in individual mode, so just as right now for regular DCCs, or in a connected mode if connected to a hub. The intent being to protect both the units, panel infrastructure, but also the upstream infrastructure at the service level, which is oftentimes needed. And what we'll do here, so just like I mentioned earlier for the SMP, we have a CT that monitors all the consumption going to the EV charger. So if we have a group of, let's say, 10 or 15 electric cars on the same transformer, we'll make sure that we distribute the power in a way that is fair and that maximize charging windows, learning the patterns of each tenant, so we can make sure that in the morning everybody has sufficient range to do their full day. If we go a bit more into technical and wiring diagram, so the hub needs a backnet cable RS485 between the hub and each of the DCC. You can daisy chain those, so going out of a hub to the nearest, the closest DCC, and then jumping to the next ones with a twisted pair cable and daisy chaining. On the hub, we have 2 backnet ports. Each backnet ports can connect up to 99 DCC plus, but at the maximum number of DCC plus per hub is 120. The limitation is really because of backnet communication limitations. So if ever you have a project that has more than 120 units, we would need to put more than 1 hub. If you currently have DCCs out there that needs an upgrade, we do sell an upgrade kit just to do the upgrade. So every DCC sold after 2020, it's a really simple procedure, 10-15 minutes of work, and you can have a fully working DCC plus. Just as a quick example or concrete application of how many, what can be the savings when you think about multi-level load management, like these applications. So this building here was fully retrofitted with the hub and DCC plus. That was a bit over a year ago, and it's been running super smoothly. They have 160 units in that building that were retrofitted for EV readiness. And what we were able to achieve was to keep the service in place, maximize the power available for EV chargers. They already have over 50 electric cars in that building, which is quite impressive because there's only 160 units total. But basically, what we were able to achieve is that they saved about $500,000 in service upgrade costs that they didn't have to do before, because they were able to keep the service and optimize their infrastructure. And they're now fully set up to electrify 100% of the stalls. And with 1 year of data, we know for a fact that we'll be able to power all of those cars when they come to the building. So deploying the hub, monitoring all the feeders, really enabled us to see what's going on at the service level and provide them with key analysis into their different options. So that was the end of my presentation in regards to control systems. So both the SMP or the DCC plus, depending on the setup, depending on the buildings, will work with any EV chargers on the market. It's also a way to bring the control closer to the infrastructure, enabling the homeowner associations or the property owner to not necessarily own the charger. They will own the control system, they will own the electric vehicle energy management system, but the charger can be owned by the tenants or the condo owner. For availability, the easiest way really is just to write to the team at sales@rve.ca or sales@rve-usa.com to know the latest availability of product or to get pricing on those different products. For the hub, we have about 100 units available right now and 300 more units coming by the end of the year. The DCC upgrade kits are available right now. They just need to be purchased with a hub because they come in combos. And for the SMP Plus, you can write to the team to order. We'll start taking orders around June, and the lead time is about 12 weeks. As a friendly reminder, we have a great team of technical support. You can see Simon on the screen, which is our electrician in residence. Simon brings over 10 years of experience in the as an electrician, and he joined us 2 years ago to help us with technical support. He's always there to support you, and also with the rest of the team at the tech support. So feel free to write to us if you have any more specific questions. So that's the end of today's presentation, and I will now jump into some questions that came in during the talk. Is this certified for standards? Okay, that's a question coming from the US. So is the kilowatt-hour billing acceptable for US standards? Yes, affirmative. Measurement Canada specification requires, I think, a 1% deviation on the precision of kilowatt-hour. So yes, it's applicable for the United States. Next question. Can the hub be used in conjunction with other EMS, like BMS system or multi-device application? So the hub uses BACnet as its core communication system. So in larger buildings, oftentimes there are already some building management systems. So technically speaking, yes, the hub could integrate to make sure that we take into consideration other appliances. I want to say that for now, our main focus really is about managing EV loads, because typically there's not that many. We'll have 200 units in a building, but only maybe 10, 15 EVs. So that's really the main focus of the company right now. But using BACnet opens us for multiple application, and with the movement of electrify everything, it's definitely a need to make sure we also understand, what's the HVAC system consumption? What's the electrical heating going to be in 10 years? So those are questions we ask ourselves daily. Our question coming from the US, are these new products currently available in the US? So we're currently in the process of doing UL 3141 for power control system. So that's kind of the highest standard in terms of certification that we can get to make sure that it's available nationwide. That being said, if you have a project or an opportunity that you think could close this year, reach out to our team, and we can look at what are the different certification that we can get for those short-term projects. So the short answer is yes, we can make it happen in the US. Just reach out to the team and we'll help you out. Next question. What is the life expectancy of the relay in the DCC? So the DCC products have been out there with the current design for a little over 5 years now. So 5 years in, we have a defect rate of less than 0.25%, meaning that those products are extremely reliable. The tests that we run on those relays are for just over 100,000 cycles. So technically speaking, it should be maybe more than 50 years. It's hard to say, But those relays are rated for over 100 amp rating, and they're extremely reliable. Yeah. While I wait on seeing if there will be other questions, just want to remind everyone that we'll be sending the recording in maybe 2 or 3 days. So if some of your colleagues have missed the presentation today, you will be able to share the link with them. I think we might have a few questions coming in, so I'll be waiting for a couple minutes. But if some of you needs to jump out, just wanted to thank you for attending today's webinar. I hope the information was useful, and that we can work on opportunities in the future and bring more electric cars on the market. Next question about GFCI protection. What about GFCI protection? Good question. I believe this comes from the United States, maybe. It's a big topic in regards to do we need upstream GFCI before a DCC installation or EV charger installation, depending on if it's a NEMA plug or a hardwired connection. I would answer to this that it depends on the local jurisdiction. The DCCs are made to operate with or without GFCI, so that would be my way to not answer your question while answering your questions. Yeah, but that's a tricky one. Good, so I think that's about it for questions now. Are there any more questions? And I know you don't see the questions in the chat on your end, but we receive all of them, and I try to reply to those as fast as possible. If there's any more questions, please feel free to ask them in the chat. Will be a pleasure to answer those. I see a few thank you. So I guess some of today's presentation was useful, hopefully. Great. So I think we can stop the recording, and I will call it a day. So thank you. Oh, we have one more question. Will the system work on a 120, 208 volt one phase? From John, affirmative, it will work. Good question, though. But anything from 208 or 240 volt at one phase, both the SMPs and the DCCs will work just fine. Okay, that's a wrap. So thank you everyone for attending today's call. It's been a pleasure, and wishing you a wonderful day. See ya.